Hey, good Sunday afternoon. It is December the 21st. 4 more days until Christmas. So I'm sitting around here like, what can I do on a Sunday afternoon? So I pulled out one of my puzzles. I like gadgets and stuff. So if you look at my desk, you see a lot of gadgets on here. I'm gonna show you one day. Calculators and but this today we're gonna focus on one of these STEM games that I found under the STEM. So STEM is STEM, is science, technology, engineering, and mathematics. And so I'm looking for something engineering that I can give to some relatives to introduce them to different terms and basic logic and design and fundamental of electrical stuff. Because we all use a light switch. Everything is going electronic, everything is electrical. So we can teach our kids, our grandkids, our neighbors' kids the basics. I love asking kids, especially neighbor kids. I'll just pop a question up there. We're walking the dog. I'll ask different questions to try to see where their interests lie and also to try to promote interest in different things or just get them sharing your wisdom, but not overwhelming them with advice or direction. Just kind of sharing a thought, working it into a conversation. So I might ask, I wonder how a light switch works. So this here is the game. So here are the pieces laid out here. So we have paths for the circuitry to go through. We have the beacons in different colors, yellow, red, and green. Just like a red light, stop sign, intersection rather. Red light, green light. No, red light, yellow light, green light. Yeah, okay, I never thought about that. All right, then you have your power supply, which is AAA batteries, 3 that I had to put into this little thing here. And you got the polarity plus, and then you have your negative on the end of it. You have your little switch here, right there, and you have your blocker here. This little piece here, though, is a little tricky. You have to decide which direction to insert it when you're doing solving your puzzle. Okay, so one tip is, so current flow out of the start token, see the start, into the side of the beacon. And it lights it, once the whole path is inserted correctly. Then the current flows out of the beacon. It flows in the positive side. See that plus sign? Also, you see the embedded circuitry line. So it goes from the plus and it goes out to the negative side of the beacon. Then on to the finished token. So this is the finished token. So this is the plus is the start, the negative is the finish. If the beacon is reversed, the current cannot pass through the beacon and it will not light. So remember, you have to follow the rules on this one. So when two beacons are located on the same pathway, even if separated by the other tokens, they must connect via opposite charge in. So if I have one here and the start is coming through the plus side, the next beacon must be negative to negative. They must connect via opposite charge in. That is positive connect to the negative. So if you inadvertently connect the beacons with similarly charged positive to positive, even if I have something in between it, if I inadvertently say positive to positive, the current cannot pass through the beacon. And the beacons will not light. Okay? So, just make sure you go over the rules if you were to get this game. I'm not endorsing it. It's just something I like. I like it because it's educational, but One thing I don't like about it is you'll see that sometimes the tokens does not seat very well into the grid. It pops out, and that's kind of frustrating. So anyway, this is how the game works. They give you a challenge. So challenge number 1 for beginners. And it tells you got beginners, intermediate, and advanced. So they're going to tell you add to the grid. Oh, sorry. Start here. You're going to set up your table, your puzzle. It's telling you the pieces you need, which would be 3. And they tell you where to put the pieces and the direction the pieces should be. Okay, so let's do this. Let's set this up. Easy, right? You can do that because it's visual. All right, so I'm going to put this in the top corner. That there. See that there. So I already know from the beginning I have to decide later where to put this end token because it's not on my puzzle. All right, here next to the start piece would be a yellow. Positive is to my left, negative is to my right. So I'm going to set that in there, seat that in there. Then I have a circuitry path here, goes here. Now this is any direction. There's no, you see the grid here? The lines embedded, telling you how the circuit's going to flow. You do that. Okay. All right. Now, my challenge is to light this beacon, the yellow beacon. Now, my portion is to add 2 corners and the end. See that right there? So adding 2 corners and an end. So now I just have to make this work. And that's where your logic come in. How do you think this is going to work? Well, we're going to eliminate the first piece is going to be the end piece. So we know it's going to be down here somewhere. So I'm going to say from the start, to get to this yellow beacon, I'm going to need a 90-degree angle, right? And you see the angles also do not have, can be used in either direction, just have a circuitry flow. So you see the line, my circuitry will go from the start through the circuit, the gray circuit. See the line there, grid? Is going to connect to my plus, because the plus need to be, remember the rule we had? When the beacon, the start token plus, need to enter the side of the plus side of the beacon. So that rule is accomplished. Now, how do I get from here to here? They tell me I need 2 corners. So we know there's going to be a piece here. So a corner goes there. Voila. There. And the last piece is this one. Now, does this have any type of directional flow on it? I would say yes, probably. I think it would, I'm going to insert it this way. And we should have a lighted beacon. See? See how that popped out? That's the only thing about this. It's easy to detect when you have 3 or 4 pieces on here, but when you have a lot of pieces on here, it's kind of hard. So you need a flat surface. All right, so I want to test, and I love testing things out. Would it work if I use the other side? It does. Okay, so that doesn't matter when you use the end piece. Okay, that's puzzle number 1. Okay, so let's check our work. So the front side is your challenge. And on the reverse card, it gives you the solution. So if you have problems, you can always reverse it inside the card and see what the solution is. And champions, we did it. We got it right. Okay, let's do another one, another beginner level. All right, so let's break down puzzle number 1. When I do this puzzle, because there's so many cards, and I don't want to go through them sequentially, so I do I'm going to the first iteration is going to be odd numbers. So I won't do every card. And then when I do it again, cycle through all my odd numbers, I will do the puzzle again doing even numbers. So I won't remember all the solutions or remember all the puzzles. So just to mix it up. All right, so I'm going to take these off, and I'm going to set up the board, the grid for the next challenge. So remove these. So this challenge here is telling us that we're going to light up 2 beacons, the red and the green. And the board is telling us we're going to need 2 corners and the start token on the board. So from the corner left here, I'm going to go this way. And it's telling you, remember, the top of the beacon is positive. So we'll go here, set that in the grid. All right. And 1 over is going to be a 90-degree angle. Now remember that you need to follow the flow of the challenge card. So don't sit it in backwards. You got to make sure it's going in the same direction. So would that be a, I know, see, would that be a right angle? What kind of angle is that? Come on, people, y'all tell me. What angle is that? I know if I'm going that a right angle or this is a right angle? I don't know. So this is going to help you with math as well. Look at that. Y'all tell me. All right, teach me. Teach Coach GrandMama. All right. And that's how you have fun with your relatives, the young relatives. They're going to be wanting to show you and teach you different things they learn. So just embrace them sharing information with you. All right, so here we go. I hope you didn't see that. I dropped it. So I have to add to this grid, of course, the 2 beacon. This is going to be easy, right? Only thing I have to do is add 2 beacons, the red, the red. I'm trying to make sure this stuff is not in your way. This will be so distracting, but the red and green, and the end, which is here automatically. So we know on each challenge you're going to have these 2 pieces, the start and the end, so that's good. All right, so I like to kind of do it because I'm older, kind of get an idea in my head mentally. But when I first did it, I was definitely using the grid. But when it got a little challenging, I'm like, I was to the point where I was going to get a piece of paper and kind of sketch it out how I think it should go. So that's a tool some people may end up using. It might be easier for them to draw it out, then put the puzzle together. All right, so remember the rule. We talked about the start polarity, positive polarity for a beacon. First must go through the beacon positive polarity as well. So we have to figure this out, right? So we know we have to be going to end up being a negative to negative, but something in between it. So that's one thing. It's going to be positive, and that's going to be a negative connection. So that can be a positive. That goes that way. So it's actually only one choice here, because if I use a positive green, it's going to point in the wrong direction. See the positive? This has to be positive to positive. So that's automatically elimination. So we know this is going to go here, right? That's easy. And you see the grid line. Line going to positive, positive. It's going through the mandatory piece that we have, the circuitry line, the flow of circuitry. So this is going to be really easy as well, because we know that the circuitry lines have to be connected some way. So to me, it's only one option. It has to go this way, right? That's going to make it connect. You can't do it this way, because it goes to nowhere. The bridge to nowhere. All right, so let me do a review of the beacon. I'm like I'm confusing myself. So when two beacons are located on the same pathway, even if separated by other tokens, they must connect via opposite charge end. So it must be positive connected to negative, which we're going to do. Okay, I was right, but it's always good to review. So that's negative. So somewhere down the stream, the next beacon has to be a positive because that's negative, right? The opposites attract. And electricity. Here you go. Okay. It's becoming a little unseated, but there we go. Of course, now the end. The end only has one place to go because the path is here, right? We already determined that you can use any, for the end, you can use any one, but I'm going ahead, just go ahead and use this here. That looks better to me for some reason. The red light kind of came on. Green light kind of came on. So this is the challenging part when the token somewhere is not. So I try to use a hard surface. Ugh. So make sure, yeah, put this back in. Yeah. Okay, there we go. I don't know how they can fix this though, but it has to be seated. Okay, so let's look at the reverse, the solution, and see if we got it right. Champions, I think you guys got it right though, right? All right, there we are. So you have the current flowing from the start token, the blue, through the red beacon, out of the red beacon to one of the path, the angle path, to the right beacon, to another angle path, to the end beacon. And you got your lights illuminated. Great job. All right. We're going to go to where I'm actually at. The last time I played this game, I stopped on 27. So I'm at an intermediate level. This is kind of challenging to me, but let's see, can we do this? So, all right, this challenge here, there's no beacons. It's just getting the circuit going. All right, so this also, you're going to allow us to insert the N token. All right. When I first got this game, this puzzle, one of my neighbors, he's an electrician. I almost went to him saying, hey, I need help with this, but I finally figured some things out. When I read back over the polarities, rules, and I also noticed, when I noticed the grid lines on there, they helped me make sure each piece grid line was flowing without obstruction. Okay, so you got that. One, 2, 3, 4. 1, 2, 3, 4. One up. Okay, got it. All right. Okay, I need an angle on the top row. In the third grid, I'm going to go this way, that way. And here's the challenge. It's telling me that this can go either way. I have to decide which is the proper direction. Yeah, that's hard. I haven't done this in a while, I forgot. But the switch is on switch, straight switch. So, I think this is my first switch. I'm sorry. This may be my first switch one. I don't remember doing a switch. So, all right, so I want to get from here. I'm missing pieces. Hold on. Okay, so tentatively there, a T, and tentatively here. All right, so I know this is wrong because the switch, if I switch this to the left, there's no path. So we know that is wrong. We know that's an easy one. Based on this is correct and that's correct. So, oh, that's easy. So, that part's easy. Now, this piece here, I'm looking at, this T is definitely not correct. Based on, I'm not going to have any pieces to the right of that. So I need that's going to be a empty, my theory. This is going to be empty. I'm not going to use this piece to get to that piece, right? So I'm going to, I'll look at this token piece as well. There's no grid piece. This might be upside down. Is it? Oh no, I see it right there. The grid line there, the circle. I was wondering, like, wait a minute. Yes, that's right, because this is not connecting to anything. That's kind of interesting. So let's see. I'm going to keep that in the back of my mind. But anyway, I'm going to make this a T. Reason being because I have a path on my switch. If I were to switch my light switch to there, the path's there, right? So I don't have anything over here, so I don't need that path going there. But I need a path up here. I need a path here. So, all right, so I think I got that set up. Even though that's probably premature, I could have did that later. But I think my piece is set up correctly. All right, so now it's telling me to add to the grid. This is a bridge, so the circuit can go under or over. See, isn't that cool? Cool. I didn't know that at first. I think that's why I needed help with my neighbor. I didn't understand this piece here. And this piece here, I think, I'm not sure what that piece is. I think I have a problem with that piece as well. So anyway, I need, sorry, I digress. I need that piece, two, I'm going to say right angle pieces. It says two, it's telling you need two. Okay. And I need a T. And I need, oh, that's a beacon. I'm sorry. Add to grid, a red beacon. Uh-oh. A red beacon. Where would I add that at? This is going to be interesting. All right, so just for starters, all right, move this out of the way. I think this will probably go this way. I'm not going to set it in yet. I'm just in my mind, just thinking something. This should go this way. And where are the extra pieces coming from? See, that's so. Now let me know my setup is not going to be correct. So I'm going to, oh, something goes there too. Okay. I got a bridge. I would think the bridge, okay. I have piece there, piece there. So I would think the bridge would probably go, the bridge go here? The bridge might go there. But how I'm going to, so I'll say the bridge will not go there. I would say a T would go here. Only because there's no connection here. The only connection to the star is in the front. So that would definitely eliminate a lot of pieces. I would think. That would go there. Let's see. All right. See how challenging this could be and how much fun it is? Because now I'm just curious. Now we know that the beacon must be positive, right? Positive to positive connection. So we know, based on those rules, this is not going to sit here because it's going to point in the opposite direction. If I put it there, I'm going to need more pieces to, I think, to get back there. Would I? Maybe. I don't know. But it can go here, but it won't connect to the T. So I would think this is a problem I have with the flow, because I don't know. Okay, I know now, but at the beginning, my circuit is coming through here. So that has to be a positive there. So that piece would not work there because the positive is right there. If I put a positive there, it goes there. So, so go here, here, switch. That mandatory. That piece is mandatory. That piece is mandatory. Oh, this piece is not necessarily in the right direction. Okay, that gives me more options. So this piece can go this way and bring it out, or it can be this way or that way. So let me pause and think for a minute. I'm about to go to pen and paper and figure this one out. I'm still on it, but let me pause to not waste your moment thinking, but think it through. Help me out here. All right. This is my draft, my preliminary. I don't understand how the switch piece works. So I don't know if the power, well, I guess the way I got it laid out, the power is going to go from here, the 90-degree angle, through this bridge, through my switch, through this 90-degree angle to my beacon, back out to the 90-degree switch. Then it's going to go over this connector to there, to the end. Let's see if that works. In my mind, it's working, but I'm not an electrician yet. I'm not one yet, but I'm telling you, this is going to make me, oh, look at that. Uh-oh. Uh-oh. It's all that red button, the red beacon. So this, like I said, this is the cumbersome part when he pops out. But so the power could, the positive polarity has to match this here. So the flow will have to go under this connector, through the switch, to this 90-degree angle, connect to the beacon 90-degree angle. And so it's flowing. Circuitry flowing out of this beacon, the negative. See the path here, going to this 90-degree angle, going through here. Now it's going over. It's going over this connector, because this is a bridge. Go over, under, go to this T, and it's going to terminate there. So it's working. Let's see if we turn the path off, the switch off. See, now it's not going to work because I have the switch open. So there's no connection. I always got confused with open and close. So now I understand it. So when the switch is open, that means there's no contact. When the switch is closed, it's a silver path in here. It's going to connect to here. That silver, see that silver path right there? So isn't that cool? See, this is very educational. I'm 60 years old and learning. All right. You see Spot take a little siesta there. But I hope that was fun for you as it was for me. I want to thank you for watching and supporting my channel by watching and subscribing. Thank you. Oh, I forgot to show you the challenge. Let's make sure we got this right. Uh-oh. Let's look at this again. All right, I forgot to look at the solution. So the solution and my solution is slightly different. The difference is the location of the beacon. So everything else is okay, and it's still a win as long as it lights up. But the beacon could have been, as you see right here, and that would have given me the 90 degree. So the polarity to the beacon polarity. Not swapping these pieces. So it doesn't matter. It works. So you see there are different ways of doing this, but this is a solution that they provided. And this is the solution that GrandMama provided. Look at that. So it's a win-win for both of us, right? All of us is a win-win. So thank you for watching again, and thank you, thank you, thank you. There's some things I want to do once I become monetized. Just get little games like this, get it out to some of the kids in the community, so we can start teaching our kids, exposing them to different things early, so they won't struggle like I did in college. Physics was hard for me. Calculus was hard, and I love math. So I love math, but I had to do a lot of work, and we really didn't have the AI technology back then in the early 90s like we have today. So let's get our kids some help in a fun way, not trying to make it difficult for them, but if they find it interesting and fun, you can learn by having fun. All right, thank you all.